What's going on, guys? Welcome back to the channel. Today we're going to be going through everything you need to know regarding logs and exponential functions. Okay, so it's a full guide for pure maths 3. Now what's important is this isn't going to be as long as some other sections, and I've basically cut out a lot of the fluff that you'll see in the textbook, right? So this is only relevant logarithmic and exponential type of content that you'll need to know that will crop up. And of course I've put a few example questions in there as well, but for the most part it's all about just understanding how to answer the equations, how to solve the equations, and how to basically work with linear graphs in order to find the values. And that's what we're going to be going through mainly. If you haven't already, guys, make sure to like, subscribe, obviously share this video with your friends if you gain value out of it. Turn that notification bell on, and I'll see you in the video. Alright, guys, so firstly what we're going to be looking at is the logarithmic function itself. Okay, so what we've got here is a function. We've got a function here as well. Now what do these functions represent? Okay, now this is important, okay, because this is the these are the two that you really need to know. Over here, we've got y is equal to e of x, okay? And over here, we've got y is equal to ln x, okay? So, put simply, e of x has this shape, okay? And e has a value of about 2.71. Okay, so this is just like saying 2.71 to the x. And as you can see, it intercepts. Okay, it intersects here the y-axis at x equals 0, right? And it intersects at y equals 1. This makes sense because if you've got x equals 0 here, y is equal to 1, right? So that makes sense. Now the inverse here is ln x, okay? And as you can see, it's complete opposite. So here we intersect the x-axis at x equals 1, okay? So with that in mind, where do we kind of move with this? Well, where these are going to be useful is basically these crop up all the time, and you'll be using ln, okay, to take to basically convert functions. Alright, and we'll get to that now. Alright, so this brings us firstly to the log rules. Okay, now these are important, and you can think of them similar to your exponential rules that you would have learnt back in year 11 or year 10 or something. So this is true for any base. Okay, so we've put log here. Could easily be ln, which is what what everyone usually uses, right? Right. So this could be ln xy, for instance. And what it's saying is, when you've got a product in the log function or the ln function, it's just going to equal to the expansion of it. So log x plus log y. Okay. Now, in that same vein, if we've got a division within the log function, it's just going to equal to the difference between the log of x and y. Okay. And what you'll see is, as you go through this, okay, and do different questions, these points are going to become more and more relevant because you're going to be inputting them and chopping and changing the form of these different rules, right? And lastly, we've got log xn. Now this one comes up a lot as well. Okay, so this is like saying, for instance, ln, okay, of x to the n, right? Which equals what? That's going to equal n ln x. Okay, that's effectively what we've done here. We've taken the n, Brought it over. So now we have n ln x. Okay. As seen here. So these are the 3 key rules you need to know. Okay. Know them off by heart. You don't have to memorize it like you would the times tables, because it's just going to become second nature to you as you go through the questions. And so without further ado, let's get into some examples where we utilize these rules. Alright guys, so starting off here, we've got some very easy type questions, okay? Very kind of simple-esque questions. So, for this one, 5 to the x equals 2. How do you solve that? Well, what we can do here is simply take ln of both sides, okay? We're going to apply ln to both sides, and if we do that, we get ln of 5 to the x is equal to ln 2. Now what rule does this look like? Well, this looks like the exponential rule, the power rule. So what we can do is we can bring the x down, and we can say x ln 5 is equal to ln 2. So x times ln 5 is equal to ln 2. So therefore, x is going to equal ln 2 over ln 5. Okay? And that's going to be the answer for that one. Very simple, as you can see. Nothing too difficult here. Now, in terms of the second question here, there's a few ways we can go about doing this, right? One interesting way you could do this is we could say this. Well, we could multiply both sides, okay, by e of x. Why do we do that? Because as you can see, that's going to give us e to the 2x minus 5e to the x, okay, plus 6. Okay, because you've got e to the x here, times by e to the negative x here, sorry, times by e to the x. Okay, and the x is plus, that's e to the 0, hence 6, right? So now we've got a quadratic equation, right? And this is just like saying e to the x squared minus 5 e to the x plus 6 equals 0. Okay, so now we've got a quadratic equation we can work with. Okay, and then factors of 6 that add to negative 5. Okay, so what we can then say is, well, e to the x minus 3 times e to the x minus 2 is going to equal 0. So therefore, e to the x is going to equal 3, or e to the x equals 2, which that means therefore, okay, that x, so we take ln of both sides, okay, if we take ln of both sides here, we get ln e to the x is equal to ln 3, which means if we take the x down, we get x ln e is going to equal to ln 3, okay, which means that x is going to equal ln 3, okay, and over here, for e to the x equaling 2, we take the ln of both sides again, ln e to the x is equal to ln 2, which means what? X ln e is going to equal ln 2, which means that therefore x is going to equal ln 2, because ln e just equals 1. Okay, and these are therefore going to be answers for number B. Alright guys, now in a situation like this, it's a little bit more tricky to apply like ln, times it by ln, right? Sorry, taking the ln of both sides, because you got ln 9x minus ln 3x plus 1 is equal to ln 54. So you get x ln 9 minus x plus 1 ln 3 is equal to ln 54. And it's just a bit of a hassle multiplying things out. Okay, and then you can lead to some difficulty. So what's quite handy about this is if you can see that there's a exponential root where you can multiply something to get something else. So you can multiply something's a root of something else, okay, or power of something else. And you could try to do it that way, because in this scenario what we've actually got is 3 to the x to the 2 minus 3 to the x plus 1, which turns into 3 to the x 3 to the 1 times 3 to the x equaling 54. Okay, because 9 is equal to 3 squared. So if 9 is equal to 3 squared, therefore 9 to the x is equal to 3 to the 2x, which is equal to 3 to the x to the power 2. Okay, I can then say let y equal 3x. So therefore we've got y squared minus 3y is equal to 54. Okay, and from there I can then say, well, if we were going to go about solving this, we could just plug this into a quadratic formula. Okay, and if we plug this in, what we get is y is equal to 9, okay, or y is equal to minus 6, aka e to the x is equal to 9, so 3 to the x is equal to 9, or 3 to the x is equal to minus 6, which means that x equals 2, and this can't be true. Okay, because we can't have 3 to x equaling minus 6. It makes no sense. So therefore, in this answer, in this question, x is going to equal 2. Alright guys, another kind of classic question that will like pop up every now and then is something like this. It's got e to the 2x plus e to the x equals 6. Right, and all you need to do here is again recognize that for a question like this, they're just testing your quadratic knowledge, quadratic equation solving problem knowledge, right? So, well, e to the 2x plus e to the x minus 6 equals 0, right? Now remember, it's the same thing as saying e to the x squared plus e to the x minus 6, right? So, if you think about it, it's like having x here, so x squared plus x minus 6. Similar kind of concept. So we see factors of negative 6, they get up to 1, so 2. Okay, so we've got e to the x plus 3, e to the x minus 2 equals 0. So e to the x is equal to minus 3, or e to the x is equal to 2. Okay. Now, if we take ln of both sides to the left, we get ln of negative 3, but that's invalid. We can't have a ln of a negative. Okay. And so, we've got ln x equals ln 2, so x ln e is equal to ln 2, so x is equal to ln 2. Okay, and that's going to be your final answer there. Alright guys, now for this question, right, we've got another kind of classic question you'd find in the exam. Okay, a little bit more realistic now. And it says, showing all necessary working, solve the equation 3 times the absolute value of 2 to the x minus 1 is equal to 2x. And I want you to give those answers correct to 3 significant figures. So the way you do this is to say, right, you just say here, let y equal 2 to the x. Okay. So therefore, what do you have? If we're letting y equal 2 to the x, therefore we have 3 times the absolute value of y minus 1 equaling y, right? And so what we can do now is square both sides. So if we square both sides, okay, we've got 3 y minus 1 squared is equal to y squared. So therefore 9 y minus 1 squared is equal to y squared. Okay. Therefore, we've got 9 here, y squared minus 2y plus 1 is equal to y squared. So can you see what we're doing here? We're turning this into a classic quadratic equation. And so we've got 9y squared minus 18y plus 9 is equal to y squared, okay? So we can simplify this. We said we've got 8y squared minus 18y plus 9 is equal to 0. Okay, and we need to factorize this now. So if we factorize this, what we get is 2y minus 3, okay, times 4y minus 3 is going to equal 0, right? Which means that y is 3 over 2, okay, 1.5, or 3 over 4, 0.75, right? Right, so therefore, we've got a value of y, our values of y, so therefore we can plug back in. We can say 2 to the x is equal to 1.5. 2 to the x is equal to 0.75. Okay, so take the ln of both sides. Right, we take the ln of both sides here. What we've got is x ln 2 is equal to ln of 1.5, or x ln 2 is equal to ln of 0.75. Which means what? Which means x, okay, is equal to ln of 1.5 over ln 2. So x equals what? 0.585. And over here, we've got x equaling ln 0.75 over ln 2. So negative 0.415. Okay, so these guys are going to be your two answers, and I said to give it to 3 significant figures, which we've done. Alright guys, so now we've got a similar type of question where it says, showing all necessary working, solve the following equation, right, to 3 decimal places. So the way we go about doing this is firstly we're going to expand out, okay? So we're going to get e to the x, okay, plus e to the minus x, alright, and that's going to equal 4 e to the x plus 1, okay? Which means that e to the x plus e to the minus x is going to equal 4e to the x plus 4, okay? Brilliant. And so, what can we say here? Well, we can simplify this down. We can say let e to the x equal y. Okay, now if e to the x is equal to y, that tells us the following. That we can get y plus 1 over y, okay, is equal to 4y plus 4. Okay? And we can then simplify this further. Okay, if we times by y, we get y squared plus 1 is equal to 4y squared plus 4y. Okay, which tells us what? Well, that tells us that 3y squared plus 4y minus 1 equals 0. Okay. Now with this, I'm just going to skip past. I'm just going to use the quadratic formula. So y is going to equal minus 4 plus minus b squared minus 4ac, okay, to the negative 3 to 1 over 2a. Okay, which means that y therefore is going to equal negative 4 plus minus root 28, okay, over 6, which means that y is going to equal negative 4 plus root 28 over 6, or of course y is equal to minus 4 minus root 28 over 6. Now this brings us to two answers. We've got, on the one hand, okay, if we plug these into our calculator, on the one hand we get y is equal to 0.2153. Okay, on the other hand we've got y is equal to negative 1.549. Which means therefore that e of x must equal 0.2153, or e of x must equal negative 1.549. Now obviously we can't have this. Why? Because you can't have a ln of a negative. Okay, so we've got x is equal to ln of 0.2153. Okay, which gives us a value of negative 1.536, okay, to 3 decimal places. And that's going to be your final answer there. Okay, so just a recap of that. You times the e to the x plus 1 to the right hand side, okay, and then you use substitution if you need to. Using that substitution, we then get to this. Okay, now we can't have ln of a negative, but we can have ln of this, and this is going to be our final answer then for x. Alright guys, now for question 4, it says solve the equation 5 ln of 4 minus 3 to the x is equal to 6, and it wants us to also show the necessary working, okay, and give the answer to 3dp. So this is relatively simple. All you have to do is the following. We're going to divide by 5 firstly. Okay, so we divide by 5. What we've got then is 4 minus 3 to the x is equal to 1.2. Okay, and if we take e of both sides, what does that tell us? Well, that we're just going to be left with 4 minus 3 to the x here, equaling e to the 1.2, right? So therefore, 4 minus 3 to the x is equal to e to the 1.2. And so we can say that 3x is equal to 4 minus e to the 1.2. Okay. And what we can say now is we take ln of both sides. So ln 3x is equal to ln of 4 minus e to the 1.2, which means that x ln 3 is equal to this, which means that x is equal to 4 minus e to the 1.2 over ln 3. Okay, which means that x is therefore going to give you negative 0.351. Okay, so just a recap of that. Very kind of standard, simple type question. All right. All we've done here is we've said, look, we need to solve this equation. Okay, we need to show all necessary working and give the answer correct at 3 decimal places. So we've taken ln of both sides. We've divided by 5 here. Okay, divided by 5. And from here, it's just been a case of saying, well, listen, we've got e to the ln of 4 minus 3x is equal to e to the 1.2. Right. And we were able to solve x as a result. Simple as that. Alright guys, now for number 5, we've got the following question. It says that the variables x and y satisfy the following equation. Y squared is equal to ae to the kx, okay? And a and k are constants. Okay, we've got the graph of ln y against x here. We've got the points that it goes through. Here, they want us to find the values of a and k to 2dp. So, here's what I can do. We can say, okay, y squared is equal to ae kx. Okay. Brilliant. And so, as a result, taking ln on both sides, we can get ln y squared is equal to ln ae kx. Okay, which gives me 2 ln y is equal to, we've got ln a plus ln ekx firstly, right? Because if we use our log rules to expand. And so what we get then is 2 ln y is equal to ln a plus kx ln e. Okay, brilliant. So now 2 ln y is equal to kx plus ln a. Okay, so this is a very common type of question. Okay, because what it's doing is it's trying to get you to turn a graph into find the values of a and k here, but usually they're trying to show you how to convert a graph from linear form into exponential form or vice versa, because a lot of the time these exponential graphs look like this. Okay, and that's not very practical for everyday scientific use, which is why a lot of the time you'll see ln graphs like this. Okay, because they've taken the ln of the graph, and as a result it's a lot easier to plot. So that's the reason why you see these types of questions. Okay, so we've got 2 ln y is equal to kx plus ln a. So ln y is k over 2 x plus ln a. Okay, that's ln a over 2. Now, we've got an equation, and we've got some points. So we just plug them in. Okay, so if we do, let's see here. We can find the gradient first off. Okay. Remember, this is our gradient formula. y1 minus y2 over x1 minus x2. So y1, y2, so 2.7. That's y2 over x1 minus x2, 5.24. Okay, which gives us what? Well, that's going to give us 0.401. Okay, so this is our gradient now. Gradient. So therefore, that's our gradient. And k over 2, okay, must equal 0.401. Okay, which means that k must therefore equal 0.8. Okay, that's going to be the answer for k. Now, we can take this a step further. This is our graph. Okay, k's are, we know what k is. Now we can just sub in our values, right? So subbing in, let's say 1.5, 1.2, call that equation 1. That gives us 1.2 is equal to 0.802 over 2 times 1.5, okay, plus a half ln A, which means that 1.2 is equal to 0.6015 plus a half ln A, which means therefore that ln A is equal to 1.197, which therefore means that A is going to equal to E over 1 times 7, which means that A is going to equal 3.31. Okay, so we found A and we found K. Okay, that's our answer. So just a recap of how we did that. So these graphs are very much all about practicality. That's the reason why they've got ln y on the y-axis, right? Instead of just y, because otherwise the graph could look something like this, which you don't want if you've got a scientific, if you're using the scientific method, right? So here we've got y squared is equal to ae to the kx. We just take ln on both sides. Okay, we go down, and eventually we get a is equal to 3.31 from k is equal to 0.8. Okay, find k first, then we find a. Alright guys, so another question here. We've got the variables x and y satisfy the relation 2 to the y is equal to 3 to the power of 1 minus 2x. Okay, and it says, by taking logarithms, show that the graph of y against x is a straight line. It then wants us to state the exact value of the gradient of that line. Okay, so how does one go about doing this? Well, let's see, right? First thing I'm going to do is I'm going to take ln to both sides. So ln to the 2y, so it's a ln of 3 minus 2x, okay? Brilliant. So now we've got y ln 2, okay, is equal to 1 minus 2x ln 3. Okay, which means that y ln 2 is equal to ln 3 minus 2 2x ln 3. Alright, so from here we can say that y, okay, is going to equal ln 3 over ln 2 minus 2x ln 3 over ln 2. Okay, which tells us what? Well, this creates a linear form, does it not? Because we now have minus 2x ln 3 over ln 2 plus ln 3 over ln 2. Okay, which we can rewrite as 2 minus 2 ln 3 over ln 2 x plus ln 3 over ln 2. And that's going to be your final answer there. Okay, in fact, actually, say the gradient. What do they want? Exact value of the gradient. Okay, so the gradient is going to be the final answer. And that should be ln 2. Alright guys, now for number B, it says find the exact x coordinate of the point of intersection of this line with the line 3 equals x. Okay, and it wants us to give your answer in the form ln A over ln B, where A and B are integers. So the way you go about doing this now is you're going to say this, right? What we're going to say is we're going to solve y equals 3x and our y simultaneously. So we can say 3x is equal to minus 2 ln 3 over ln 2x plus ln 3 over ln 2. Okay? Brilliant. So we can now say, well, 3x ln 2 is equal to minus 2 ln 3x plus ln 3. Right, so therefore 3x ln 2 plus 2 ln 3x is equal to ln 3. Now if we take the x out here, 3 ln 2 plus 2 ln 3, which equals ln 3. Okay, and therefore x is going to equal ln 3 over 3 ln 2 plus 2 ln 3, which corresponds to x equaling ln 3 over ln 8 plus ln 9. Okay, because why? Because the 3 here is going on top of the 2. 2 to the 3. The 2 here is going on top of the 3. 3 to the 2, so 8 and 9 respectively. And so as a result, x equals ln 3 over ln 72. Okay, and that's going to be your final answer for B.